So looking at your flow chart, that's the last page of your notes again. When you look at your flow chart, you should go through that process. Again, the very first thing you want to ask yourself is this limit approaching one of the infinities? This is yes, approaching one of the infinities. Then I need to go and look at this and figure out, is this top heavy, is this bottom heavy, or is it neutral? Because I only have a top, it is top heavy, which means I have no variable in the denominator, which means that I am going to take a look at this as the limit as x approaches negative infinity of x cubed only. So what I have to think to myself is, what would happen if I take an enormous number that's negative and take it to the third power? Is it going to become positive? Will it stay negative? Is it very large? Is it very small? Is it zero? And I hope both of you guys, or all of you guys, recognize that this would be a negative infinity answer. There is my limit. So that problem now is done. It was approaching infinity. I took the lead terms and reduced them. I ended up with only a number on top. I could put it over 1 if I wanted to. So I have to imagine what's going to happen if I plug an infinity in there. So another one like that. The limit as x approaches positive infinity. It's an infinity. Now I do have a numerator and denominator, so I isolate the highest powers and I reduce them. I'm down to only a constant. That's my limit. So see how quick limits can go if you know what you're looking at. They can be quick. Next one, it's an infinity. Isolate the highest powers, get rid of everything else, reduce it down. This one is bottom heavy. Bottom heavy means 0. If you don't remember that, then just try. Plug in something like 1 over 9,999,999 divided by, like, in your calculator. It should come out to, if it doesn't show up as 0, it'll come out to really darn close to 0 because it is, again, bottom heavy. So 0 is my limit. We just went through those first 3 without hardly having to do any math at all. But in problem number 4, what if it's not approaching infinity? Those first 3 shortcuts, again, only apply to infinity. And now, when I go and look at my flow chart that we looked at, I can't go down this yes side anymore. If it's not approaching infinity, I have to go down this no side. And so all the rest of the problems are going to deal with those steps. Well, the first thing that I have to look at, is this a constant? No, it's not just a number by itself. There is a function here. So what am I going to do? I'm going to plug in 4 and see if I get an answer. And I do get an answer. I believe that it's 2. I need you guys to maybe check the math on that. 2 divided by 16. Yeah, I'm pretty sure it's 2. Done. Again, that's my limit. I plugged it in, I got an answer, I'm done. Well, then why did we spend all this time doing all those tables and all that difficult stuff? Because there are going to be instances where it's not approaching infinity and it doesn't work out nicely. But when it does, that is it. Believe it or not, that's all I have to do. Plug it in, done, that's my limit. What if my function is a trig function? Doesn't change anything. If it's not approaching infinity, I plug it in. So I'm looking at the value of the cosecant of 2 times 3 pi over 4, which is the value of the cosecant of, when I simplify that down, 3 pi over 2. If I have a calculator in radians that offers a cosecant, yeah, you can plug it in. But remember, 3 pi over 2 is down here. It's in that bottom point. That's the point 0, -1. The cosecant is the reciprocal of the sine. So I flip the sign, and there is my limit. Same with number 6. It's not approaching infinity, so I plug it in. This is 2 times the secant of 0. 0's over. Can't see it on my sheet, but 0's over on the side there. That's the point 1 comma 0. Secant is the reciprocal of the sine, or cosine rather, reciprocal of the cosine. So this is 2 times the secant of 0 is 1. My final answer is 2. Those first 6 problems we plowed through. The last 6 are going to require a little more work. The last 6 are the ones that, all right, it didn't work when I plugged it in. It's not approaching infinity. Now I have to rely on some of my history of math. So we're going to spend a little bit more time on these guys. But I'm going to start the same way, because just because I see a problem like this doesn't automatically mean that I'm going to end up with something bad happen. So I'm still going to plug this value in here. So I'm going to evaluate the square root of 3 minus 2 minus 1 over 3 minus 3. Well, that equals 0 over 0. I said yesterday in your notes that that should raise a red flag. This is an issue. That means that algebraically this can be simplified some way. The first way I try to do it is to factor, but I don't know how to factor this. So my other way to do it is to use the conjugate. Do you guys remember the conjugate? Does that ring a bell? Talking about how we use the concept of a difference of squares. I lost my favorite pen. Oh, here it is. Okay. I saved my favorite pen for the conjugate. Okay. I'm kidding, I don't really. But I'm going to take this square root of x minus 2 minus 1 over x minus 3, and I'm going to multiply the top and the bottom by the square root of x minus 2 plus 1 over the square root of x minus 2 plus 1. Same thing on the top and the bottom. Remember, multiplying by the same thing on the top and the bottom means we're multiplying by 1, so I don't change the value, I just change the look. But the whole point of doing that here is going to help me on the top, because the square root of x minus 2 times the square root of x minus 2 will leave me with x minus 2, and the minus 1 plus 1 will leave me with minus 1, and the middle terms, the outer inner combination, the square root of x minus 2 times 1 and the square root of x minus 2 times negative 1 are going to end up canceling each other out. So I get rid of the radical there, but on the bottom I'm going to leave it as x minus 3 times the square root of x minus 2 plus 1. And then, if you look closely, you should notice that x minus 2 minus 1 is the same as x minus 3, which means that the top and that piece of the bottom cancel out. So when all is said and done, I'm going to redo this limit as x approaches 3, but I'm going to change the look of the function into its simpler form and evaluate there. So I'm left with 1 because this whole top, remember, canceled out. That became x minus 3. The whole top canceled out, so I had to replace it with 1. And then this is the square root of x minus 2 plus 1. So my new limit is 1 over 3 minus 2, which is 1. The square root of 1 is 1. 1 plus 1 is 1 over 2. So I had a little bit of work to do there. In problem number 8, I recognize again that I have a radical in this problem. It's not approaching infinity, so my next option is plug it in. 25 minus 25 over the square root of 25 minus 5 is 0 over 0. Again, that should raise a red flag. And my first instinct might be to apply the conjugate. However, there is a way that I can factor this problem that is not something that we normally see or look at or would necessarily kind of think to do. But I can use the concept of a difference of squares. And I can take that top and rewrite it as the square root of x plus 5 times the square root of x minus 5. That's a use of the difference of squares that is not typical. And when I see this, I couldn't do that here because it had the x minus 2 underneath there, but when this is just left with x underneath there, I can use that concept. In fact, I can use the concept of a different squares no matter what I have. If I had x minus 7, as long as it's a difference, I can write that as the square root of x plus 7 times the square root of x minus 7. Sorry, the square root of 7. The square root of x plus the square root of 7, I can just take the square root of each piece, and if I multiplied that all together, it would be that. And if I recognize that breaking that down is going to benefit me, I'm going to be able to cross off part of this value. And then I can reevaluate my limit. The limit as x approaches 25 of, let me make some room, the square root of x plus 5, which is 10. New limit. Got to get rid of that problem because it is going to get in my way of my next stuff. But any questions on that whole sort of conjugate thing or factoring thing? Notice these are a little more difficult. It's okay, they're doable. You just have to use some algebra, okay? For the next two, you're going to have to do some algebra as well. They're also a little different, and we haven't seen problems like this here, but we have seen problems like these in other places in our history of math. And so when I take my limit, it's not approaching infinity, so I can just plug it in. I will end up again with a 0 over 0, which raises a red flag. I'll get 0 over 1 over negative 2 plus 1 over 2. So that's negative 1/2 plus 1/2, which would be 0. 0 over 0, undefined. This is not a conjugate situation. Can't use the conjugate here. It's not going to help me. It's also not a factorable situation. But what I can do is I can simplify this fraction. And there are multiple ways of doing it. But one way is to multiply the whole fraction by the common denominator. So I'm going to take the x over 1 over negative 2 plus x plus 1 over 2. And I'm going to multiply it by the common denominator in the denominator. So I'm going to multiply it by negative 2 plus x times 2 over negative 2 plus x times 2. Again, multiplying it by 1, but in doing that, multiplying by the common denominator on the top and on the bottom, what I'm able to do is cancel out the denominators on the bottom. So this is going to be rewritten as x times negative 2 plus x times 2 on the top. But on the bottom, the first fraction, the negative 2 plus x will cancel out. That will leave me with 2 plus the second fraction, the 2 will cancel out, leaving me with the negative 2 plus x. How does that benefit me? The negative 2 plus negative 2 will cancel out, leaving me with x times negative 2 plus x times 2 over x. And the x's will cancel out, leaving me with the limit as x approaches 0 of negative 2 plus x times 2, or negative 4. Final answer. Again, there are other ways to do this, but if I multiply by the common denominator in the fractions in the denominator on the top and on the bottom, it'll wipe out the denominators and leave me with a simplified fraction. I kind of want to go through that same process again because it's a little bit kind of confusing. Sometimes it's a little scary to do that. So before I move on, are there any questions on what happened there? Are we okay? Feel all right? Okay. So let's go ahead and try our next one. Again, when I plug it in, I should end up with 1 over, I'm not approaching infinity, so I just plug it in. 1 over negative 3 plus 0, which is negative 1/3, plus 1/3 is 0 over 0. A red flag pops up, but I can't factor. I can't use the conjugate, so I'm going to have to simplify. One over negative 3 plus x plus 1 over 3 all over x. I will multiply by the common denominator, which is negative 3 plus x times 3 over negative 3 plus x times 3. This time my denominator was in the numerator of the fraction that I was looking at, whereas last time the denominator was in the denominator of the fraction. I know that's weird, but these are complex fractions, so it's fractions within fractions, and I'm working with the complex part of it. So when I multiply that through, I get 3 plus negative 3 plus x over x times negative 3 plus x times 3. So in the first one, when I multiplied it, the negative 3 plus x canceled out, left me with 3. Second one, the 3 canceled out, left me with the negative 3 plus x. So that's how my numerator came. On the bottom, I have the x times the whole thing. Again, the top will be replaced with an x. 3 plus negative 3 is gone, which allows me to cross out the x's, which leaves me with a limit as x approaches 0 of 1 over negative 3 plus x times 3, or negative 1/9, and there's my limit. Again, these 4 problems, they were not approaching infinity. They did not come out nicely when I plugged in the value, so I had to pull out factoring, a conjugate, a simplifying, some algebra. Those are the toughest types of problems that you're going to see. So my last type of scenario that can happen, the last thing that'll show up, is another sort of interesting thing, but on our flow chart, it says, did you get 0 over 0? But it says, did you get a value? No. Did you get 0 over 0? No. Then the only other thing that could have happened is you got something over 0, some number over 0 that makes it undefined. And if it's undefined, then I'm going to have to do some other work. And so I can make a little table for my asymptote. That's what we have here. These go pretty quickly again. So this is, plug it in, plug the value in. It's not approaching infinity. Plug it in. I get 16 over 0. This is undefined. Undefined typically means I have an asymptote. I'm only interested in the right of 4, so I'm going to plug in 4.001, and I just plug it into the original function. I don't even really plug it in. I just imagine. What happens if I take 4 times 4.001? Well, it comes out positive. I don't care what it comes out to be. I just care that it comes out positive. What happens when I plug in 4.001 minus 4? It also comes out positive. Because both of these are positive, my answer is positive infinity. Because I'm only caring about the one side, I'm done. That's it. That's my answer. What if I care about both sides? Well, then I have to check to the left and to the right. And that's our very, very last example, and then I'm going to let you try some practice problems on your own. So in this one, I have the same situation. It's not approaching infinity, so I plug it in. I get negative 5 over 0, which is undefined. So I make a little float, or make a little table, not even that full-size table. Remember the big ones that we made? Not even the full-size table. All I care about is just to the left of negative 5, of 5, so 4.999, and just to the right of 5, 5.001, and I want to envision what's going on. I'm going to treat it as negative x over x minus 5, so I'm going to plug this in. I get a negative over a negative, so this side is positive infinity. Plug it in on the other side, I get a negative over a positive, so this side is negative infinity. Do these things match? If they don't, then my limit does not exist. So those are all the scenarios that we have. I'm going to hand out a sheet for you to work on, practice. Your job is to do all of the evens and 23. So it's the evens and 23. If you want to do more for more practice, obviously do more. All right?